Hello everyone. So today we are learning about logarithms. The first thing we have to learn is equivalent statements. We know that there's a very strong correlation between indices and log, and therefore we need to know, it is really important for us to know how to convert them. So if we have an index number like 2 power 3 equals to 8, how do we convert this into a log equation? It is really easy. All you have to do is focus on the base value for the index number over here. We know that the base value is 2, and therefore if we move 2 across the equal sign to become the base number of log, we will get 3 equals to log 2, 8. So this is how we convert an index number to log. So just a repeat, if we have something that is 10 power x equals to y, so this is the same. We have to look at the base number here and bring it across the equal sign to become the base number of log, and therefore x will be equal to log 10y. So if we know how to convert an index equation into a log equation, how do we convert them back? Well, it's the same thing. So if we have a log equation, for example, 3 equals to log 2, 8, the base number for log in this case is 2, and therefore 2 will become the base number for the index number over here. So 2 power 3 will be equal to 8. We always have to bear in mind that it's the base number that's carried across the equal sign, but not the other numbers. So just as a repeat, if x equals to log 10y, we know that the base number for log is 10, and therefore if we carry this across the equal sign, it's going to be 10 power x equals to y. So we understand that if a power x equals to y, then the logarithm of y to the base of a will equal to x. Okay, so that would mean that if the base number over here is a, if we change it to log, the a is gonna be the base number for the log, and and it's carried across, so it's gonna be a log a y equals to x. And we always have to note that both the a value and the y value must always be bigger than 0. So they have to always be positive. So why do we use log? So we know that they are interrelated. So if you can solve a question using indices, I encourage you to do that because that's an easier way. But if we can't do it, I'll show you in the next examples. If you can't do it, then you have to use log. So in a very easy equation, we know that 2 power 2 equals to 4. So if there's a question, for example, 2 power x equals to 8, what will the value of x be? Very easily, we know that x will equal to 3. Yeah. So what if there's a question like 2 power x equals to 6, and what is the value of x? Yeah. So we know that 6 is between 4 and 8. And therefore, if 2x equals to 6, 2x will be in between 2 power 2 and 2 power 3. So we know that x is a 2 point something, but we don't actually know it for sure unless we can solve it using log. So this is a situation where log comes in as a part of like a solution process. So how do we evaluate evaluate log numbers? So for example, if we have log 216, so log 216, let's say, equals to x, and we have to find the value of x. Yeah. So if we change this log equation to an index equation over here, all we have to do is move the base number for the log across the equal sign to become the base number for the index. Yeah. So we know that 16 is equivalent to 2 power 4. So 2 power 4 will equal to 2 power x. If the base numbers are the same, we know that the exponents will also be the same as well, and therefore x equals 4. So in another example, what is the value of log 3 1 over 9? So if we let log 3 1 over 9 equals to x, and we change this into an index equation. So we know that 1 over 9 will be equivalent to 3 power x. And if we convert 1 over 9 to become 3 power 1 over 2, we will know that x will equal to negative 2 because the base numbers are the same. Yep. So to answer the question, the previous question about what's the value of x when 2 power x equals to 6, well, we solve it the same way. We convert this into a log equation where the base number, which is base 2, becomes the base number for log. So in order to get the value of x, we can use the calculator. So let me just show you very quickly over here. So yes, as done before, log 6 will give us a value of 2.58496. So how do we get this value? We can actually access this using our TI Inspire CAS software. So it's just control and 10 power x. Can you see on top here? There's a log function here. So all you have to do is press control and press this. You will get the log function. So just put 2 and 6 and you would have gotten the value. In order to get the decimal, so we will just press control enter. So now, because log and index are interrelated, so that the laws are pretty much the same as well. So if we need to simplify a power m times a power n, we know that if the base numbers are the same, we just have to add the exponents together. And if we have a power m divided by a power n, we know that it's actually a m take n, because when it is a divide, we actually take the numbers. Yep. So for example, how do we simplify a power 5 times a power 3? Yep, we will just add the exponents together and this will become a power 8. So how do we simplify a power 5 divided by a power 3? Yep, we will just take the exponents. So 5 take 3 will give us an a power 2. So log laws are the same. So if we see log am plus log an and the base numbers are the same. Yep. So when it's plus, it's related to time. So we can actually times the numbers together if the base number are the same. So similarly, if there is a negative, a minus, so log am take log an, this will be equivalent to log am divided by n. Yep. So for example, if we want to solve log a5 plus log a2, we can actually times 5 and 2 together, which gives us log a10. So if we have log a5 take log a2, we will get log a5 divided by 2, which is log a2.5 here. So other laws and properties, other than the two laws mentioned just now, there are other laws that we have to know to be able to solve questions or equations or problems related to log. Yeah. So another law that we have to know is log a x power n. We can actually bring the exponent down to become n log ax. Yeah. For example, okay, 3 log 5x is equivalent to log 5x power 3. So log a1 equals to 0. So we know that as long as there's a 1 here, yep, a can be any positive value, and the value of the overall value will become 0. That's because if we switch this into an index number, whatever number power to 0 will always return as 1. So for example, log 1 equals to 0. Yep, log any number with 1 will always equal to 0. Yep. So log a equals to 1. We can actually cancel a log base a value to become 1 when both numbers are the same. That's because if you convert this into an index number, a will equal to a power 1. Yep. So we can actually, if there's a log 7, we can actually cancel this to become 1. So if there is a log a 1 over x, yep, a 1 over x is the same as x power negative 1, and therefore, according to the first law over here, we can actually bring the exponent down to become a negative log ax. Yep. So how do we simplify or evaluate a log equation like this? So log 5, 1 over 25 will be equivalent to log 5, 5 power negative 2. So we can actually bring the exponent to the front as what we discussed previously. So negative 2 log 5, 5 will be equal to negative 2 because log 5, 5 can cancel to be 1. Negative 2 times 1 will be negative 2. So that's the end of the lesson today. And stay safe, everyone, and see you next time.